Welcome back. Thank you for joining me for another day of simplifying fractions with radicals. So, before we jump in, we are going to continue our review for our final exam. So, our first one, what are the solutions to x squared minus 4 equals 0? Now, here we have a squared term and a constant. So, this is a perfect opportunity to solve by square rooting. How do I solve by square rooting? Well, I need to add the 4 to the other side, and then I need to square root both sides. And when I square root both sides, remember that's when we get a plus or minus. By square rooting inside of an equation, you must get the plus or minus. Now, foiling, when we have two binomial expressions being multiplied, the way that we handle that is by the foiling process. Now, foiling, remember, means first, so I get 4x squared, last, oh, I'm sorry, I'm jumping ahead of myself. I don't want to do last next. So first, to get 4x squared, outside to get 10x, inside to get negative 10x, and last to get negative 25. Now notice what happens. 10x minus 10x actually cancels out. So what are we left with? Well, we're left with 4x squared minus 25. And then finding the vertex. Now remember the vertex, that is going to be that highest or lowest point of a parabola. So when I'm finding the vertex, being asked for the coordinates, well, it hasn't moved at all on the x-axis. And on the y-axis, it's moved up 1. So there is our little bit of review for your final exam. Now, when we're talking about radicals, simplifying radicals, remember, when you square root a fraction, you can consider that as the same as square rooting the top and square rooting the bottom individually. Okay, so that's one of our key components to this. So let's keep going. So simplifying radical expressions. Now, when we're looking at this, the first thing we always want to do is see if we can reduce the fraction as is. Well, 64 over 49. Well, that doesn't reduce at all as a fraction. So we need to just start pulling it apart. Well, the cool thing is, if you consider both of those numbers, you should recall those from our list, 64 and 49. Well, the square root of 64 is 8. The square root of 49 is 7. So that's what I mean by pulling apart the fraction. Just take the square root of the top and the square root of the bottom. Now, of course, it can get a little bit more complicated than that. So let's look at something like this. So, like I said, we always want to reduce our fractions first, okay? So before we even consider the square root, let's simplify the inside of that radical. So 8 over 50. Well, I can reduce both of those by 2. So I'm going to get 4 over 25. X cubed divided by x. So I'm starting with an x cubed and I'm taking away an x to the first. So 3 minus 1 will leave me an x squared on top. So now that we have that, we're done reducing our fraction. So now I'm going to square root the top, the 4x squared, and I'm going to square root the bottom. So, looking at the top, well, the square root of 4 is 2. Square root of x squared, remember we talked about this previously in our notes. Square root of x squared is just x. And the square root of 25 is 5. So that's kind of the power of being able to reduce your fractions, because it makes it a whole lot easier to take the square roots. So let's keep working. So 144 divided by 9. Now if you type that into the calculator, the square root, or 144 divided by 9, actually is just 16. And you should note 16 is a perfect square. So when you square root 16, you get 4. All right, looking at our next one. So once again, we can actually simplify that fraction, reduce that fraction before we even begin. 36 divided by 4. Well, 36 divided by 4 gives you a 9. A divided by a cubed. So a to the first, taking away a cubed, 1 minus 3 gives me an exponent of negative 2. Now, the exponent of negative 2, recall, means that I need to put it on the bottom, because there it will be a positive exponent. And now that I've reduced my fraction, I can take the square root of both pieces. So square root of 9 gives me 3. Square root of a squared will just give me back my a. All right, and looking at the last one on this page. So 25y cubed over z squared. So for this one, it's not really looking like I can reduce my fraction at all. So I just really have to start pulling it apart. Well, the thing that I notice is I have a y to the 3. Now remember, we don't really like odd exponents in these square roots. So what I'm going to do is I'm going to pull that apart to be y squared times y to the first. Okay, so remember, when you have a variable to an odd power, just start breaking it up. So, why are we doing that? Well, because the square root of 25 just gives me 5. Square root of y squared gives me y. Now, unfortunately, I do still have that one y sitting by itself left inside. That's why we pulled it apart, so we could see the piece that pulls out. And then the square root of z squared just gives us z. And there's our answer. All right, so continuing on to the next page. Now, when we're looking at these, for these ones, now sometimes we're actually going to have to rationalize the denominator, because 3/7 doesn't reduce, and if you try to take the square root of 3, it's not a nice number. Try taking the square root of 7, not a nice number. So remember, in this case, we cannot have a radical in the denominator. So what I end up doing to remedy that problem is I'm going to multiply top and bottom by that radical that's in the denominator. And the reason that I do that is now on top, square root of 3 times the square root of 7, since both are inside the radical, those combine to 21. Now remember, a radical times itself, the square root of 7 times the square root of 7, ends up giving you back the number inside. So that'll just be 7. Because you would get the square root of 49, but again, when you get good at this, you can just jump straight to knowing that that would be the number 7. And so now you can see that you no longer have your radical in the denominator, so we know that we are done with this one. Now the next one, before you try to rationalize the denominator, the first thing that you can do is if you notice that you can simplify the radical, you should do so first. What I mean by that is the square root of 8. You can pull a square root of 4 out of that. Okay? So the square root of 8 is the square root of 4 times the square root of 2. So you'll have this. Now, the reason I'm having you do that first is it'll save you some reducing later on in the problem, if you can remember to reduce that first. Because now, notice, even after I simplify the radical, I still have a radical in the denominator. So what I'm going to do is I'm going to multiply top and bottom by that radical that I'm trying to get rid of. So on top, square root of 7 times the square root of 2n, well, since both are inside the radical, I can actually multiply them together to get 14n. On the bottom, I have that 2, and now square root of 2n times the square root of 2n. A radical times itself just gives you whatever was inside, so the 2n. And finally, looking at this, 2 times 2n, I can actually just call that 4n. And now I'm done. So don't forget the power of simplifying your radicals first to save you complications and reducing later on in the problem. So looking at our next one, square root of 2 divided by square root of 3. Can't reduce the fraction, and I can't simplify either radical. So it's time to rationalize the denominator. Multiply the top and bottom by the radical you're trying to get rid of. So on top, square root of 2 times square root of 3, since both are inside the radical, turns into the square root of 6. On the bottom, a radical times itself is going to give you the number that was inside. So it just gives you the 3, and in this case, we're actually already finished. Looking at our next one, square root of 5 over square root of 18m. So looking at that 18, that actually has a number that can pull out. Okay, square root of 18, you can actually pull a 9 out of that and be left with a 2m inside the radical. And again, the reason I'm pulling that out is because that square root of 9 becomes a 3. So I've simplified my radical expression now. So now it's time to multiply top and bottom by that radical I'm trying to get rid of, by the square root of 2m. So on top, square root of 5 times the square root of 2m, because it's all inside the radical, I can multiply it to get square root of 10m. On the bottom, I have 3, and then square root of 2m times square root of 2m. A radical times itself will give me back the radical that was inside. So I just get 2m. And now that 3 times 2m, I can actually just call that 6m and be done. All right, our next example, square root of 7s divided by square root of 3. I can't reduce the fraction. I can't simplify either radical expression, so I can just jump straight into rationalizing the denominator. Well, on top, square root of 7s and square root of 3 are both inside the radical, So I can actually multiply them together to get square root of 21s. Then on the bottom, a square root times itself will always just give you the number that was inside. All right. So, moving right along. Square root of 15x over x cubed. So, looking at this, the first thing that I want to do is I want to simplify and reduce the fraction first. So I have the 15. Now, x over x cubed. We can actually simplify that piece of the fraction. X to the first, take away x cubed, 1 minus 3. Well, that's going to give me a negative 2, which means it is a positive 2 in the denominator. So now when I go to take the square root of the top and bottom individually, I want you to notice something cool that happens. While the square root of 15 we can't do anything with, on the bottom, the square root of x squared is actually just x. So by doing that reducing first, by reducing the fraction, we actually eliminated the step of having to rationalize the denominator. It took care of itself completely for us. And now we're already done with our problem. The square root in the denominator is gone. All right, so looking at our next one, square root of 5 divided by square root of 3. All right, well, we can't reduce the fraction, and we can't simplify either radical expression. So it looks like here we're going to jump straight into rationalizing the denominator. So on top, square root of 5 times square root of 3, since both are inside the radical, I can call that square root of 15. And on the bottom, square root of 3 times square root of 3, well, multiplying a radical times itself will just give you back the number that was inside. And our last one. So here, for this one to reduce it first, since everything has a square root, this is one of those times we can actually reconstruct it. So if both the top and the bottom of your fraction are completely inside a square root, you can just combine it, just like when you were multiplying, okay? And the reason I'm doing that is because 6 over 2 actually just gives me 3. So by doing that, I can actually reduce my fraction a little bit because 6 divided by 2 gives me 3. So now when I think about them independently, oops, I apologize. So now when I'm trying to rationalize my denominator, it actually turns out to be much easier without having the 6 over 2n completely. Because now on top, both are inside the radical, so they multiply to 3n. On the bottom, a radical times itself just gives you back whatever was inside. And now we're finished. All right, so thank you for joining me. I realize that this can be a lot of material. However, these are all great practice problems. So thank you for joining me for this. Make sure you have everything written down, and then we will continue our practice work in class.